Finally, this is the day when we learn how to convert a complete naked chart to a data frame, and then how we can convert that data frame to a code and you can make your strategy, and then how we can convert that code to the dollars, right? And if you want the percentage, then what you can do, you can just divide this by the initial price. So final minus initial upon initial, right? So you will have 50 upon 100 and you will get as 0.5, means 50% you are in profit. Now if you want, you can change the kind of this, so you can make it as, and you will get a bar chart, correct? Good morning friends, welcome back to day 26 of the 100 days of hell with Python algo trading. Finally, this is the day when we learn how to convert a complete naked chart to a data frame, and then how we can convert that data frame to a code and you can make your strategy, and then how we can convert that code to the dollars, right? So I will not recommend you to skip this video. If you are available, then only watch this video. Please do not watch this video without your full focus. Watch only when you are fully focused, fully concentrated, and fully dedicated, right? So if you are currently busy somewhere, please save this video for later, because today we will understand the most important functions and attributes of Pandas series and DataFrame, which you will be using a lot while creating any strategy or any algorithm for your trading. And also, this is the video for those people who always say that please skip the fundamental part and directly move to the algo trading. But in actual, I would say 70% is your basic and fundamentals, because if you are good enough in your basic and fundamentals, then the algo trading will become so smooth for you. So that's why I always say, please focus on your basics, and once we are done with that, then it becomes a piece of cake. So as we have seen previously, that how we can convert chart data, the OHLC, open, high, low, close, to a data frame, and then we can convert the data frame, and then we can use that data frame for our algorithm, and then ultimately we can convert that algorithm to some dollars, right? So let me quickly revise the OHLCV again. So previously we have seen that in the red candle, this is the open, this is the close, this is high, and this is low, correct? Similarly, in a green candle, this is the open. Let me show you another candle. This is the open in a green candle. This is the close, this is the high, and this is the low. And again, this is the volume, right? Basically, you have open, close, high, low, and the volume V. So OHLCV, correct? So that can be converted to a data frame. And why we convert to a data frame? Because in code, we need some series, we need some numbers, we need some integers, and that's why we convert a chart to a data frame. And that can be easily analyzed, that can be easily manipulated, and so on and so forth. So our main agenda for today is that we will learn some functions which are critical, which are important while learning the algo trading. And if you learn these attributes and methods, then I can assure you that it will become a lot easier and simpler for you to create any algorithm, to convert any chart to a code. So what I have done, I have categorized the methods for Pandas series, the methods for Pandas DataFrame, and the methods which can be applied on both the Pandas series and Pandas DataFrame, right? If you can see on the screen, then we have these methods for the Pandas series and these many methods for the Pandas DataFrame, right? And these are the methods which can be applied on both the series and DataFrame. And many of these functions we have already learned, and remaining we will learn in this session. So what we will do today, we will practice some real life based algo trading scenarios, and you will see that how in real life we convert, and how in real life we work on data, how we clean the data, how we analyze the data, and how we can manipulate the data in real life algo trading scenarios. So then, without a further ado, let's get started. Before starting the video, let me tell you something that we have two CSV files, right? So in the first file, we have data of the traditional stock, the crypto data, and in the second file, we have the fundamental research data. So generally, when we want to go long term in any stock, that time we use the fundamental research, and that is also sometimes crucial, right? And one more thing, that this data is synthetic, right? Synthetic means this is not the original data from any source. It was randomly created by the code. So I have shared both the codes for both the data sets, and you can use this code as per your requirements. You can change some values, you can change anything, and you can use it as per your requirement. So I'll push this also to the GitHub. You can clone the repo from there and you can use that, right? Okay, now, as I have already explained you the agenda for today, that what we will do, we have two data sets and we will try to perform various operations which we generally perform in the real life algo trading scenarios, right? So in order to achieve that, first we will clean the data. Then we will analyze the data and finally show you the data. So what I'll do, I'll just import the CSV files here. So pd.read.csv, and I will give the name of the file. The first one is algo trading combined dataset. And what I'll do here, I will give this the name, let's say algo df. Let's make this consistent because we have worked on this dataset previously, so it will be easier for you also to understand, right? The next is pd read csv, and the name of the file is fundamental research dataset, and let's give this data frame the name as funda df. Let's hit shift enter and try to check out the data. So the first one is algo df, which is this one, and the second one is the funda df. So in the first data frame, algo df, we have 32,870 rows and 7 columns, which is basically a OHLC data. And the second data frame is the funda df. In that, we have 1,050 rows and 10 columns. So in that data frame, we have the fundamental analysis, the fundamental values, and on which we can do the fundamental research. And again, let me reiterate this, that both of these data frame are randomly generated data, right? So there is no real value here. The first question is identify all the top performing stocks based on their overall return from the start to the end of the data set, right? That means, so let's print the data frame. And what this is saying, that we want to display the top performing stocks, right? From the start to end. So let's first check that how many number of stocks we have in this data frame. So for that, what we can do, we can check with the ticker. So let's print the value of ticker here. And when we do that, you will get 32,000 rows. But we want the unique values. So for that, we can use the function unique, right? And you will get an array of unique values. And so you can see that we have Apple, Google, Microsoft, Amazon, Tesla, Euro USD, GBP USD, USD JPY, AUD USD, USD CAD, BTC USD, ETH USD, XRP USD, LTC, BCHN, and nothing. So means we have a mix of traditional stocks, the forex pairs, and the crypto pairs. Our main goal here is to sort these stocks based on their performance, and we can say in descending order, right? So we have seen that in the algo df data frame, we have the starting date is 1st January 2015 and the end date is 18th of September 2020, right? So if you want to understand this in the chart, we bought a share at this, right? And let me highlight this. And that time date was 2015, 1st January, right? And I sold the stock at this place, right? And we can say that time date was 2029, 18th of September 2020, right? Means all these values are, these 32,870 rows are all these candles. I think it's clear, right? So now we can calculate on open or close. So generally we select close. So what we will do, we will check that from this date, the first one, to the end, which stock performed very well, right? In this time frame, which stocks performed very well out of the stocks we have just seen in the array, right? So, and we will check and the closing price of this date, whether the stock was in profit or whether it was in loss. Okay, now let's understand with the code. We want to find out the percentage return from the buy and the sale date, right? So what we can do here, we can make this array as a variable. So I'll assign it, let's say, a name, and it can be tickers, right? So at least if I want somewhere, I can use this, and let me print this tickers, and you will get these value. And if you want any particular value, let's say the first value, you will get Apple. If last value, you will get the BCH USD, correct? Then what we can do, we will create an empty list, because in that list, we will store the final values. So let's say I'll give it the name as top the performance. Let's say it can be anything, good or bad. Performance and empty list. Hope it's clear up to this point. Now, let me print it again here. Now what I'll do, I'll run a for loop. So for ticker and tickers, we are running a for loop on this tickers. We have seen the tickers array of all the unique tickers. So let me show you again. Print ticker. So you will get all the tickers, correct? The unique ones. In reality, we have these many rows, but many of the rows have the same ticker. So that's why what we did, we extracted the unique values out of this data frame. Now, what I want to do, I want to print one by one the tickers. So you can print like Algo, and then the ticker is equal to ticker. The main thing is here, we want to print one by one. Like the first, we will extract all the values of Apple, then Google, then Microsoft. And once we have all the rows of Apple, then we can perform some operations, the operations which have been asked in the question, and it becomes a little bit easier for us, right? So I can show you this again also on the sideline. So let's print this here. Actually, this is nothing but a filter. So let's say at the place of ticker, we have Apple, and when I hit enter, we will get a Boolean series, right? And we have seen that if I want the filter data frame, what we can do, we can make it as a mask. So I'll make it a mask. And now I'll again write the name Algo df, and you will get a filter data frame with only the rows containing Apple, right? So same thing is happening here, right? So for that, what I will do, I will just make it as a mask, and I'll write Algo df. Hope it's clear up to this point, right? I can give here the name, let's say stock, correct? And then what I will do, I will print stock, the close of Apple. So let me show you here again. So what we will do, let's say I assign it a name, and let's say test stock, and then test stock, and only the close column. And let's give it the name as test stock, and let's print the close column of this test stock. So we know that this one is the column, right? Same thing is happening here. And now we want to calculate the performance. So how we can calculate the performance? So we know that, let's say if you bought any stock here, right? So this was the close of this candle, and you sold here, right? So both values we are taking the close only. So how we can find the performance? Means the price of the stock here was 100, right? Then it shoot up, and here it was 150. So now how you can calculate the performance? You just have to subtract the last price, the final price. You can say here the final price when you sold. So the final minus the initial price when you bought, right? And you will get the 50, correct? And if you want the percentage, then what you can do, you can just divide this by the initial price. So final minus initial upon initial, right? So you will have 50 upon 100, and you will get as 0.5, means 50% you are in profit. Same thing is happening here. What we are doing, let's say we find out that this is the first close price and this is the last close price. So what we will do, we'll just subtract this value to this, and we'll divide by the initial price, right? And we'll get the percentage performance of that value. So here, and now to extract the last column, what we will do, we'll apply iLock, right? The index and we can just give -1, and I'll just copy and paste. We know that the first value you can get from the 0 and the last value we can get with the -1, right? And we have to divide it with the first value. So I will just enclose this in a bracket and I'll divide it with this value. So what you will get as NaN. So now you know that what is the issue with the missing values and how we handle them. So let's say I'll change it to Amazon and check with that. And yes, now we have 0.03, means Amazon performed -3%. Means whenever you bought the price and when you sold, your amount was, your value, your net worth was 3% less. Means it didn't perform very well. So same thing we will apply with this loop on all these stocks, right? Start with Apple and end with BCH. Hope it's clear. I tried my best to explain you. Still you have any doubt, please let me know if we need to change our teaching style. Okay? What I will do, I will just copy this and paste it here, and I'll just remove this test because that is the name we are having here, which is stock. Right? We can assign a variable here, let's say overall return, right? For each stock. So as we are running a for loop here, so one by one we'll get all the values, right? And let's give this the name stock data. Now what we will do, we will store these value in this empty list, right? So what I will do, I will just append this performance dot append, and I will give here, let's say, so what we can do here, first we can write the ticker name, which is this one, right? Ticker. So I'll just write here the ticker. So what we are doing here, we are appending a dictionary, and that we have two values, two key value pairs. The first is ticker and the name of the ticker. So the first will be Apple and the respective value of that ticker. So here we have found out the return. So what I'll do here, I'll write as overall return. What will happen here, the ticker name and the return, the overall return will be stored in this empty list. Now what we can do here, we can simply pass this list. So how do we create a data frame with a list? We have seen that previously. PD dot data frame, and then we'll pass this empty list here. So initially it was empty, but now it is not empty, right? And one more thing we can do here is that we can sort the values. That we can do with the ticker name, right? Overall return. This will be a column, right? So we can sort with the return. So we get the result in the descending order. So for that, we have to pass it here, and here we can say ascending is equals to false, right? So now when I hit shift enter, you will get the value, and you will see that the topmost performing asset is USD CAD and the lowest is the LTC USD, or you can say these three stocks we're not able to perform because of the missing values, or we can say NN values. It's very straightforward. You just have to focus this time. So once you have understood these 10 questions, I'm sure that in future you will have no issues performing these kind of operations. Correct? So here we can do one more thing, that we can assign to a new data frame, that is return df, and then we can print this one, return df. We can also set the index of this with set index, and we have seen that we have to give the name of column which we want to make the index. So it's the ticker, and now we have a series, right? So for that you have to check that return df, actually here you have to write in place is equals to, and now you have a new data frame, and which is a series. You can check that with the type. One more thing is remaining, that is you have to squeeze it, right? Which we have seen previously, and now you will get a series. Correct? And if you want, you can also keep it as data frame also. And here you can also plot this. So let's say plot, and you will have a plot, right? With the top performing asset as the USD, and the last one is the BCH, which is not here because it didn't have any value. So the last one is BTC, right? Now, if you want, you can change the kind of this. So you can make it as, and you will get a bar chart, correct? And for these, the X label, Y label, we will learn in future when we learn about the matplotlib. And if you want to understand now, then let me know in the comments. So from the next session, what I will do, I'll explain you the matplotlib along with the pandas, right? Now, one more thing which is missing here, that how to handle these values, because sometime in the real life scenarios, you cannot just missing values or 3 stocks unattended, right? So you have to do something with these. So for that, what you can do, before starting the analysis, you can clean the data, right? So for that, we have to treat the NN values. For that, what I will do, for now, I'll just comment out this and I'll print the algo df again here, and we'll run the function info. And you can see here that we have total 32,870 entries, and we have missing values in these columns, the open, high, low, and close. But for now, we know that we are only dealing with the close column, right? So what we can do, we can just take the close column and let's check the number of NN values here. So what we will do, we'll write is NA, and it will give us the Boolean series. And again, what we can do here, we have seen previously that we can write sum here, and it will give the total number of missing values, which is 1941. So now we have few options. One option is to remove the NN values, and another option is to fill these values with some another value. So generally in algo trading, what we do, we fill these values with something similar to the one value above or one value below. So we have two options, the backfill and the forward fill. So now what we'll do, we'll fill these values. So we'll write fill NA, and here we have an option which is forward fill. Here we have a parameter which is method is equals to forward fill, and then when we hit shift enter, you will see that all the NN values have been filled with their previous value. You can see here that this NN value was same like this one also is having the same value. So what is the benefit of this? That now we will not get the error which we were getting in previously, that 3 stock pairs didn't even able to find any value, right? So here you can see that this method is deprecated. So for that, we can find another way. So this is your homework, that you find any alternate way that how you can achieve this result with any other method or function, right? And here in place is equals to true, correct? So when I hit shift enter, now it has been changed, and now when I again check this and is NA, and I apply sum here, and now it says 0, means now everything is okay. So what I will do, I'll again go here and uncomment this, right? And now when we check, you will see that we have the value of Apple, which was earlier missing. And again, I guess this BCH USD or some other values which were earlier missing, but now we have all the values. And I can show you again with this also. When I remove this plot, you will see that earlier we had 3 NN values. Yeah, that was this for the first question. You let me know if you have any issues, any problem. You can let me know in the comments, and we can discuss that again, right? Okay, the next question we have is, how many instances of daily price change greater than 5% occurred for each stock, right? So for that, what we will do, first I'll print the data frame, and what we want to know, that how many days when this close was greater than the open, right, for every day. And we know that this one row stands for 1 day. So what we will do now, first of all, we have to check the none values and n values. So for that, we know that we can check with info function, and it will show us that how many no null values we have. So you can see here that we have many NN values, and if you want to know exactly how many, then you can apply is NA function, and it will show you the Boolean data frame, and then you can apply sum on that, and it will give you exact how many values are NAN. So you have to deal with these values, otherwise it will create some problem which we have seen previously. So for that, what we can do, we have just done that recently. We'll just apply the function fill NA, and inside that we can use the method backfill or forward fill. So in forward fill, what will happen? The value with the previous row, it will fill exactly the same. So here I'll apply forward fill, and we can also make it in place true, so it will not create issue again, right? So it's done. So now if I check again, the NN values algo df is NA, and then I apply sum on that, so it will show me 0. Means now we do not have any NN values, right? So now we can proceed comfortably with our question. So the question is the percentage change. So for that, what we can do, we can apply a function that is percentage change, which we have understood recently. So what I will do here, I'll apply PCT change, and we have to apply on particular column actually. So actually here we just want to check the particular column that is close. So I'll apply on this close, and then I can apply PCT change, and it will give me another column with the percentage change. And what it will do, it will compare with the previous day, right? Always. So now what you can do, you can create another column in this data frame, and let's say give it the name as algo df and daily change, right? And I'll hit shift enter, and we have another column. Let me show you this one, right? Daily change. So in that, the first is NaN value. And why? Because for the first day, there was no reference value, right? Because in PCT change, it calculates with the previous value. So the first value, it will always be NaN value, correct? Now we want to check greater than 5%. So for that, what we can do, I can apply a filter on this daily change, and I can write like daily change greater than 0.05, and it will return a Boolean series, and on that I can use that as a mask, and I'll get a data frame which is only having the daily change more than 5%, right? So we can also store this in another column. So let's say I'll make the column name as high change and hit shift enter. And now let's check. And you will see that it says cannot set a data frame with multiple columns to the single column high change. Actually, it is a data frame. So for that, actually for now, what we can do, we can just store the Boolean series as it is. So I'll create a column with the Boolean series itself. High change is equals to this. And now when I check my data frame, we have a new column, right? Now it's very easy. So for that, what we can do, which we have performed in the last step. So we'll find the unique ticker names. So for that, what we'll do, algo df ticker, and we'll get an array with the unique values. So I'll assign it with the new variable that is tickers. And now we can run a for loop on this. So for ticker in tickers and algo df ticker equal to ticker, right? And I'll close this in a parenthesis, and another condition that is daily change. So this should be true for that particular ticker. So I'll also close this in another. And now what we can do, we can make this whole filter as a mask, and I'll apply on the algo df. So now we have only those values with the ticker and having more than 5% change daily. I can store this in another variable, and let's say high change tickers, and also to store this value, we can have another dictionary. So I'll create a dictionary, let's say occurrence, and is equals to an empty dictionary, and here we can store that. So occurrence and the ticker name is equal to the high change tickers, right? Like for the first ticker Apple, the value whatever it gets, it will get stored in this. And again for the next Amazon. So what is happening here, we have an empty dictionary here. Now in the for loop, for each ticker the value, so here we want the instance. So for that, what we can do, we can apply shape here, and for that also the number of rows, right? So now let's check and print the occurrence here, and let's see. And you'll see that we have a dictionary with the exact number of times that particular ticker had more than 5% daily change, right? And let me show you this outside for your better understanding. So I can test this on any ticker. So instead of ticker here, we can take Apple. You can see here, these are the number of rows when the change was more than 5%, right? So we can calculate the shape of this. Shape is 37 rows and 9 columns. So then what we want only the number of rows. So I'll apply 0 here, the first item. And when we hit shift enter, we got 37 here. And if you want to check for any other, let's say Tesla, so you can just change here to Tesla and you will get 33, which is here also, right? You can even check for LTC USD. Let's check this also. This is just to make you understand, because here we have multiple tickers, and that's why we have to apply a for loop here. If we had only single ticker, then we could have done that in just a single line, right? Hope it's clear to you. Now what we want to plot a chart of this. So for that, we need to convert this dictionary into a data frame. And we know that this is just a 1D dictionary. So for that, what we will do, we'll just convert these keys to a list. So what I'll do here, I'll write a list and occurrence dot keys. So you will get this list with the keys. And again, I'll pass this inside the data frame. So you will get a data frame, right, with just a single column. But we know that we want the values also. So for that, you can just write columns, and inside that you can pass a list. And the first you can have is the value, or you can have the ticker. And second you can have is the, actually here we need to make it as items, not the key. And then you will get a data frame, right? So now let's assign it to a variable, that is df. And now when I print df, you will get this. And you can also set the index as the ticker, and let's set it, and we can make it as permanent. So in place is equals to true, and you will see that it is now permanent. So now when I check df, we'll get this value, right? And now if you want to plot this, you can plot, and you will get a nice and beautiful chart. And but now you can make it a bar chart that will look more meaningful, right? So you can see here we have Apple, Google with all the charts. You can even sort this. That's completely up to you how you want to manipulate the data. Okay, now let's move to the next question, which is calculate the number of times each stock's price increased in the first quarter, right? Actually, I will not solve all the problems. I'll just solve this third, and again you can solve 1 or 2 problems from the different data set, right? And then I'll leave all up to you. So you try to solve, and if you face any issue, then you can let me know in the comments, and we can discuss that in the future, right? So let's understand this problem. It says calculate the number of times each stock's price increased in the first quarter. Now we need only the values from the first quarter. First quarter means only the January, Feb or March. So for that, you have to think and pause the video and think that how we can achieve that. And then I will discuss the approach. Okay. Okay, let's start this. So first we'll print the data frame Algo DF, and inside that, what we want only the first quarter, right? So for that, what you will do, you need to have understanding of time series. And actually, we will dedicatedly learn this time series in the future lectures. But for now, just understand one function and let me show you. So what we will do, we will convert this date column to a time series index, right? So I'll just write date, correct? And here I can use the function as pd dot to date time. And inside that I can pass this column, and I'll replace this with the new value. So let me first show you the changes, right? So now if you check the type of this column before applying the function to date time, you will see that this is just a normal series, right? So after converting this, and now if you check this, you will see that it has changed to, okay, we have to make this in place. Now what we want to do, we want to check the data type of all these columns. So for that, you can just write info, and you will see that now this date is just a object data type, right? But we want this date column as the date time data type. So for that, what you can do, you can use the function pd dot to date time, and here you can pass the column here. So algo df and date, and when you hit shift enter, and now when you check algo df dot info, you will see that now what we want to convert this. So currently this is object data type, and let me show you how. So when I check date, you will see that the D type is object, but we want in date time. So for that, what you can do, you can just apply the function to date time. So I'll write pd dot to date time, and here I can pass this column name, correct? And also I can replace this old column with the new one. So when I hit shift enter, and now when I check this column, you will see that it has been changed to date time 64, right? And that is exactly what we wanted. So now I will just comment this out for now. Okay, now let's extract only the values from the first quarter, that is January, February, and March. So let's try that. Okay, algo df, and here we can use this dt dot month. This is all the magic of this date time function here, right? And when you hit shift enter, you will see that we have a data frame with only the months. The 1 means January, or the 3 means March. But here we want only the first quarter, that is 1, 2, and 3. So for that, we can use the function isIn, and we can pass a list here that 1, 2, 3. So means it will check whether these rows are 1, 2, or 3, means January, February, or March. If it is true, then it will return us a Boolean series. So let me hit shift enter, and you will see that we have a Boolean series, correct? So now what I will do, I'll just store this in another variable, and let's say we first make this as a mask, and I'll write algo df, and now we have only the values from January, February, and March, and we can even check with a sample. Let me store it in another variable, let's say first quarter, right? And if you check a sample, you can take sample of 20 values. You will see that all the values are only from the January, Feb, and March. You can see here 2, 1, 3, 2, 1, 3, 2, 1, right? Means the first objective is completed. Now we want to check the number of times each stock's price increased in the first quarter. Means every day when was the close was higher than the open, right? So, and also you want to check the number of counts, number of times. So for that, first we have to find only the close values which are more than the open value. So for that, what I will do, I'll write first quarter close is greater than the first quarter open, right? And again, we will get a Boolean series here, and we can make it as a mask, and we can get the values. So only these rows when the close price was greater than the open price, right? Now it becomes very simple. So I'll just, and now what we can do, we can assign it as the variable again, the first quarter. So we'll get a modified first quarter. And now we have only the rows which is from the first quarter, and the close is higher than the open. It means we can say only the values in the first quarter when the stock price was increased, right? From the open to close, correct? And now we just have to count the number of times for each ticker, right? Like for the Apple, how many times, for the BTC USD, how many times. And you know, for that we have a very simple function. So let me show you. I can just check this on ticker, and we can just count value counts here. And when I shift enter, and you will see that we have a nice and beautiful data frame with the number of counts. And this is that simple. Okay, so I can write here the increase counts, and if you want, you can also plot this and you will have a nice and beautiful chart. But again, here also you go and you will have this bar chart, right? You can also manipulate this in a preference, the ascending or descending order as per your requirement. So that was it for this data set. And I would say this date time function is really very, very important. So please practice this few more questions. Now, that is it for the day. And I will leave this remaining questions for you. So I'll just push this data set and this notebook to the GitHub. So you can clone from there and please practice. And because these questions are really important, it will build your fundamental, right? So yeah, that is for the day. And we'll see you in the next video. Until then, bye bye, take care, have a nice day.